answers. So we've got 70, 71, and this is lesson 29, and this is solve quadratic equations, and I'm just going to abbreviate that. Oh, I know. I didn't know that, but I should know that. Thank you. It should come up. Now let's see if it does. Yes. Thank you. One button I didn't push, and I have to do that. Thank you. Thank you. Thank you. There we go. I can get that off there. Okay. Now we got it. Solve quadratic equations using square roots. I don't know that you use this one a whole lot, especially when we get the quadratic formula coming up. Wednesday, we're going to do the quadratic formula, and then we're going to do it on the calculator. You'll want your calculator Wednesday anyway because it's some heavy arithmetic, so you'll want it anyway as we start doing these. So bring your calculator with you all the time. I think most of you do. But this is probably simpler, and sometimes people might actually teach it before factoring. And I'm going to refer back to lesson 27, and we may have to come back to 28. We'll see. And today is the 11th. Let's see, what did we say the page number was? 70. Today's the 11th. And this was the first lesson I did with regular when we came back. So after Christmas, they had done this lesson, this one before Christmas, and then we did this one, and then we did complex. So theirs was a little bit out of order. So when I did this lesson with them, they didn't have any complex answers in it. First, remember that quadratic equations are of the form ax squared plus bx plus c equals 0. And I think in the video and in the notes the other day, I forgot to say a can't be 0. A can't be 0 because if it is, you don't have a squared, and if you don't have a squared, then you don't have a degree of 2, and you don't have 2 solutions. So you have to have a number, you have to have an x squared in every one of these. Now, before I start to say I would do that first, but I think I'm going to go ahead and set up these as we go through them. So we're just going to jump into them. They look a little bit different because this is what you have to make them look like. If you remember, they have to be in that format to factor them. And we had one, and I know you had some in the classwork, that everything was not on one side and you had to move the stuff over. Well, that's not going to happen. It can happen in these, and that's where when we do the quadratic formula on Wednesday, I think I can show you where you've kind of got some choices. In most problems, you try to factor them first, but every quadratic's not going to factor. And especially if you make them up, if I do x squared plus 6x plus 1, that is not going to factor. Not in the real number system, not in the rational number system. There's no factors of 1 that'll give you a 6 in the middle. So factoring is kind of a small part of it, and we dabble in this, and then we open the big door into this quadratic formula that's going to actually solve all of them, whether they factor, whether they won't factor, whether they have irrational, complex, whatever kind of answers. But we're going to start pretty much with just a basic one, and what happens is this one doesn't have an x term. It has an x squared, see, a is 1. If you move this over, it would be x squared minus 4, which actually would factor, but we're doing them a little bit different. When you do them this way, you want to get now we're going to do 2 kinds. We're going to do on this page the ones that you can get x squared by itself. Get your squared term. Actually, I think that's what I wrote. Let's do that because it could be different variables. Let's say get squared term by itself. And then you're going to want to take the square root of it. And I don't know that we've done that. But, you know, if I have x plus 7 equals 12 and I subtract 7 from both sides, as long as I do the same thing to both sides, if I do square root of one side, I can do square root of the other. If I square one side, I can square the other. We may have done that, not sure. I don't know that we've come up to those yet, but there's all kinds of things. As long as you do it to one side, you can do it to the other. So if x squared is equal to 4, we're going to literally take the square root of x squared and the square root of 4. Now, it is quadratic because it's squared, and we knew all quadratics have two answers. Well, what are the two answers? X is what's the classic answer? Square root of 4 is 2, but what's the other answer? Or x is negative 2. And that's what you have to remember. It's quadratic, and that's because 2 times 2 is 4, and also negative 2 times negative 2 is positive 4. So that's the reason that works. Now, if you, most of the time, want to compact those. Now, ACT is probably going to write them like this, 2, negative 2, and they usually put them in sets, and that's the way they're going to write it. If you want to compact that, you can put positive or negative 2 like that. Now, I like that notation. It's quicker, it's faster to me. It's just, there's my two answers, positive 2 or negative 2. And we tend to say positive or negative 2. Sometimes we even say plus or minus 2, which is kind of weird that we say it as plus or minus. But it's both or, one or the other. Not and. It's not both of them at the same time. Number 2, let's do the same thing. Let's do x squared is equal to 18. Okay, x squared is by itself. Divide. Square root of both sides. X equals, now I'm going to go ahead and put my plus or minus there, because I can go ahead and get my two solutions. Several of them in my regular class didn't like the plus or minus notation. They wrote them separate like we did here. Now, it is square root of 18, but will square root of 18 break down?
Not entirely. Like it might have some ones on the outside, some on the inside.
Okay, so square root of 18, the factor tree is 2 times 3 times 3. So it's going to be the square root of 3 squared times 2, which is going to be plus or minus 3 square root of 2. That's an irrational answer because square root of 2 is irrational, 1 point, whatever, and I don't have one of my little boxes, but again, I probably do down here in the recycle box. Let me see if I see one of those. Remember when we talked about answers, the first one here had 2 rational answers. The second one has 2 irrational answers, but they're still in the real number set. This one would not have factored over the rational numbers because the answers are not rational. Now let's throw into the mix the complex ones. So let's do x squared is equal to, how about, let's do negative 28. Okay, square root, square root. So I've got x equals plus or minus, so we need to break down the square root of negative 28. Negative 1 times, what's 28 going to factor into? Where would you start? 4 times 7, so it's 2 squared times 7. Let's just write it. I think I can go on to that step. I think you're okay with that. So do you see I'm going to have a 2 on the outside, I'm going to have an I on the outside, and I'm going to have a 7 left inside. So now you have gotten the first case where you have a quadratic that would not factor over the rational numbers, and the answers are actually complex numbers that are not real. They fall into this imaginary part. Okay. Number 4. Let's do x squared minus 9 is equal to 21. Okay, I'm going to draw an arrow up there to my rule. You don't want to take the square root until you get your x squared by itself. So let's add 9 to both sides. And we get x squared is equal to 30. Square root, x equals plus or minus. And if you don't like the plus or minus notation, you can separate them, 2 answers. Now, will 30 break down?
Not entirely. You have to make one be on the outside.
Is it going to be? It's 2 times 3 times 5, isn't it? So no repeating, no perfect square in it, so it's just square root of 30. So I kind of wanted to show you that you have a variety of those. Number 5. Let's do 100 k squared minus 6 is equal to 3. Now, I tried to stick with rational numbers on these, just so you didn't have to go back and do some rationalizing. We don't have to do a lot of rationalizing, but occasionally, and when we run into that, we'll talk about it. But the quadratic formula is going to do so much for us that our mathematicians, you know, and they didn't name it after themselves. They named it the quadratic formula for solving quadratic equations, and they can get, and it makes the arithmetic so much easier as we do them. But anyway, I need to get k squared by itself. Well, there's a couple of things going on here. To get it by itself, let's add the 6, and I get 100k squared is equal to 9. Now, even though 100 is a perfect square, you still need to go ahead and divide by 100, because what if that had been 17k squared or 20k squared? They're not perfect squares, and that would have been a case where you got irrational answers that needed to be rationalized. But these are nice, pretty ones, because we'll get k squared is equal to 9 over 100, square root, k equals plus or minus. Now, I'm going to go up here and write something. I'm going to write the square root of 9 over the square root of 100. I'm going to separate it like that, so that I think you'll see pretty easily what the answers are. Now, I don't really know what they were doing. My regular class I don't know if they were dividing it as a decimal and then trying to do square root, but in this case, we know the square root of 9 is 3, and we know the square root of 100 is 10, and so your two answers are plus or minus 3/10. That's the easiest. Now, if you do 9 divided by 10 and 9 divided by 100 and do square root on your calculator, it's going to give you 0.3, and you've got the two plus or minus answers as you're going through them.
Answers as decimals?
Ma'am?
Is it okay if, like, on the stuff, we write our answers as decimals?
I prefer fractions right now because it's going to be a lot easier, because what if it comes out like 4/3? And when you do that, we just don't do bar notation a lot in our upper math classes. We usually go back and do math frac. So if you write it as a decimal, hit math frac and go back and change it to a fraction. I think no, it's not wrong. If you write it correct, don't round, I'm okay with it, but I prefer fractions. They're just a little bit easier. What would they do on the ACT? I'm not sure. We'll have to look at some of those. Okay, that's pretty much it when you have just a k squared.